So hello and welcome to this video. My name is Arvin, and in this video I'm going to show a quick demonstration of using Intel Quartus Prime on FPGA. So Intel Quartus Prime is a programmable logic device design software produced by Intel. And FPGA, which stands for Field Programmable Gate Array, is a hardware circuit that a user can program to carry out one or more logical operations. The circuit itself consists of a matrix of configurable logic blocks known as CLB. These blocks are connected and the connections are configurable. And FPGA helps in this modern app, and it is used in many kinds of industrial area, and one of them is artificial intelligence. The key point is being that the advantages of FPGA technologies. First is the flexibility. FPGA is reprogrammable to fit the requirements, unlike chips which need a complete remanufacture. And next is the parallelism. FPGA can handle multiple workloads while keeping a high performance level, and it can also adapt to change workloads by switching among several programs. And decreased latency. FPGA has large memory bandwidth than a regular GPU, and reducing the latency and allowing it to process large amount of data. Last but not least, the energy efficiency. As we have known that machine learning and deep learning are resource-hungry solutions. However, FPGA allows high level performance at low power. Also, FPGA can even outperform GPUs when running deep neural networks interface models. Okay, so that's all for the quick introduction, and now we can head to the demonstration. So this I'm currently running on Pop! OS 2010, and this is the terminal window. So first and foremost, I'm going to create a new folder named test and enter. And next, I'm going to run the Quartus software by typing Quartus, hit enter. Okay, so this is the Quartus software, and first we are going to create a new project and hit to File, New, and select this new Quartus Prime project and hit OK. Okay, so this is the new project widget window, and hit Next. Here, this text field here is the directory of the project. So I'm going to choose the folder that I made just now, which is test, and hit choose. Next is this text field is the name of the project, and I'm going to name the project as test. And next, and this create a new empty project. Next, and this we leave it, and next. So for this, make sure that the family, this family is Cyclone 5 is selected, and for the rest of this, leave it as it is. And next, here, make sure that the model sim alterer is selected, and the rest leave it as it is. And next, and here is the summary of the new project, and we can hit finish. Okay, so the new project has been created, and first here in this new project we are going to create a new file, and this which is called as block diagram or schematic file. So this will be our workspace where we are going to create a new a logic OR here, and to do that we can select this symbol tool in this toolbar and click the drop down, select primitives, and go to logic and find OR. Okay, so this is it. We have OR2, OR3, OR4, and so on. So the numbers here signifies the number of inputs. So for this demo, I'm going to choose the one with 2 inputs, and hit OK. Okay, so left click to create to put this OR, and next I'm going to choose two inputs, and the inputs are located in this pin and input. Okay, left click to put these inputs, and finally we are going to put the output. Okay, and left click it here and press escape key to dismiss. Okay, so next we're going to connect these inputs with the OR as well as the outputs, and to do that we can select this orthogonal node tool and drag this to the OR logic, and as well as the second input, drag this to this, the OR logic. Okay, so it seems that this is not connected. Okay. Okay, the line, something's wrong with the line. It's going to delete this. Okay, delete this, and okay. So we connect the line. Okay, so now it's connected. I'm going to organize. Wait, I just need to remove these lines to create a new line by using this orthogonal tool. Okay, next connecting this OR logic with this output. Okay, and I'm going to reorganize the inputs and as well as the outputs. Next, I'm going to rename the inputs. So rename it to in underscore A, and the second input will be in underscore B. Okay, for the output, I'm going to rename it as out. Okay, so this is it for the OR logic. So I'm going to save this file save as, and make sure that the name of the file is the same as the project or this top level instance here. So hit save, and next we can compile this logic here, this workflow, and to do that we can hit to this processing and hit this start compilation. Okay, so this compilation will take a while. Okay, so the compilation is successful, and now we're going to create a waveform file. So to do that, we can hit the file, new, and go to this file or debugging files and select University Program VWF and hit OK. So this will be the window for the waveform file, and here we are going to right click in this panel here and select insert node or bus, and then more node finder, and finally you select list to list all of the nodes here. So if there is no any node appear here, which means you has not yet done the compilation before the main workspace. And next, and you need to compile first in order to allow these nodes to show up here. So we are going to select this button here which copy all of the selected node lists, and okay, it's now selected, and we can hit OK. OK, and now the 3 nodes appear here. So we have not yet input anything here, and for the output it's still nothing here, nothing shows up here because we have not yet run the simulation. Okay, so first we are going to head to the edit menu and set this end time. So make sure to change the unit to nanoseconds and set it to 100. Okay, and next set up the grid size. Okay, period 10 and nanosecond. Hit OK, and now select the in A node and click edit, value, and override the clock. So make sure the period is 10 and hit OK. Okay, again we are going to select this in B node and hit edit and value, override clock. So for the second node, set the period into 20 nanoseconds and hit OK. And now we can save this file and name this as test waveform. Save, and now we can finally run the simulation by tapping either of these 2 buttons here. The first one is run functional simulation, and the second will be run timing simulation. So there are 2 kinds of simulation here, and the reason behind this simulation is the first one, to see if the logic is correct, and that is the function of this functional simulation button here. The second one is to see the effects of propagation delay in the circuit, and it is the function of this timing simulation. Okay, so first we are going to run the functional simulation here. Okay, so it seems that we have an error. So to solve this error, we can head to this simulation and simulation setting. In this Verilog, change the waveform here in this line into the name of the waveform file. So it will be test underscore waveform. And next, head to the timing simulation setting and change this line as well. There is a quick alternative. By clicking this restore defaults, it will set the this name into the file name automatically. And now we can hit save and rerun the functional simulation. Okay, so this select yes. Okay, so it seems there is another error, and it says that no VOPT option has no effect, and it is now deprecated and will be removed in further release. Okay, so we can head back to the simulation setting, and now we need to remove this no VOPT in this line, as well as the line of code in timing simulation, and remove this no VOPT and hit save. Okay, so we can now rerun the functional simulation again. Okay, so a new window will pop up, and this will be the result of the functional simulation. And now we can see this is the result of the OR logic. So 0 0 0 1 0 1 0 1 1 1 1 1, and so on. It will keep repeating until the end time, which is 100 nanoseconds. Okay, so next, moving on to the timing simulation. The second button here, click it and it will start the simulation. Okay, so the actual reason why we have this functional and timing simulations. So as I have already explained before, that the first functional is used to check that whether the logic is correct or wrong. So during this functional simulation, if the logic is wrong, there is no point in looking at the delays. Okay, so for this reason, the simulations is divided into this functional and timing simulation. Okay, so that's all for this demonstration, and thank you for watching.